Welcome to our third lecture on machine learning fundamentals. On our previous lecture, I showed you some examples of regression problems. Just to recall, regression models are those models which help us to predict the numerical variable. A number is something which is measured, yes? So we are, for example, predicting the price houses and or customer lifetime value, which was measured in US dollars. Now we are going to change the type of the prediction to classification, and classification is the situation in which we want to predict the label categorical variable. Okay, so as you probably remember, it's a very, very fundamental distinction. We'll have completely different ways of gathering data, creating the label, preprocessing data, or maybe not by preprocessing, but for example, measuring the quality of the model or just simply choosing the algorithm. Okay, so we have regression, we have classification, extremely important distinction. So today we are going to cover examples, first examples of classification. So let me share, but before we start, maybe you have some questions, comments concerning our previous lecture. If not, once again, because I can't see your faces, it's difficult for me to interact with you. Whenever you have any question, comment, just don't hesitate to interrupt me. That will make our lecture more interactive. Okay, so let me share the screen with you. And so, what's the goal for today? We are going to go through, hopefully, 4 examples, but I guess it won't be that easy. So for sure, we are going to cover the first example, which is the high revenue prediction of whether the new customer which comes to your store is gonna be a high revenue for you or not. And next we'll go to churn modeling. So this is the modeling of the situation that someone leaves your company to the competitor, for example, just simply stops paying the subscription. Next example will be on credit scoring in banks. So imagine that someone comes to you and wants to, for example, get another extra credit on a credit card, and the question is whether this person will pay those debts on time or will default on this debt. So this is credit scoring. And then finally, the example of the reaction of the customer to the marketing message. We try to model whether the customer will purchase or not when we call him with the offer. And those are the most typical examples of application of classification problems in business. Obviously, I'm aware that this is not the course on artificial intelligence in business. That's why I will use those examples to illustrate different topics from data engineering, modeling, deployment, and for example, maybe some label definitions. So a lot of different practical tips for today. So, and once again, whenever you have some questions, just please ask. We start with the first example. So as always, I will create a new project, a blank project, which I'm gonna call high ref. Okay. And as always, I will start with data. I need to open and import my dataset. So now we are going to spend some time on different data sources. And one remark, it may happen that I'm gonna start talking to you about topics which I already covered. If it is so, if I said something which was previously covered in our previous meetings, yes, just please tell me, okay? Because it's close to impossible to control everything, and then I will just simply will avoid the repetition. So as far as I remember, we were not talking about different data sources, did we?
I don't think so.
Yes, so let's start with this. So Once again, from practical perspective, imagine that you are a data scientist hired by some company which wants to solve some of its problems with machine learning. That's very fashionable nowadays. And the general flow is the following. The first workshop is just to identify the business goals. Okay, it may happen that there are a lot of different ideas on the table. Different decision makers come with their own vision. How can AI may be applied to their business? Sometimes they have already chosen the use case because they have found it somewhere. So it depends. But at the end of this workshop, fortunately, we end up with the precise goal for our project. In our case, the first example is the high revenue of the customers. This is the same case we had a week ago with Regression. So we are the e-commerce company. We sell t-shirts globally, and in that case precisely, having historical data on our customers' behavior, we'd like to create the model which for a new customer, someone new to us, yes, it will predict whether this person will leave a lot of money with us, that means high revenue, or low revenue. So that's a moderate amount, and yeah. So this is the goal. Okay, so we have the first workshop. We know the problem. So the next step, that's why I stopped here, is to create the first so-called proof of concept. Okay, this is my idea. How do I work with customers? I avoid planning for a few years ahead with huge projects because it's close to impossible to deliver them with a given scope, budget, and time. It's much better to use agile methodologies like Scrum, and it's being materialized in the way that the first sprint lasts for around, I don't know, a week or so, and its goal is to create so-called proof of concept. Okay, this is the very, very simple example. We take the data we have at hand in the easiest possible format, just a percentage of the whole data if it's a big data, and we train so-called baseline model. So this is not the fancy model. This is the first approach, just to get the feeling whether this is doable, the problem is solvable. Yes, so this is so-called proof of concept. Okay, having that, next we plan for the next iterations. Okay, and now when it comes to data, at that stage, the most common format of the data is a comma-separated value, and this is what we have here. You have probably heard about this, or I even showed it previously. So we'll just simply repeat. Comma-separated value is a text file, although if I double-click this file, it will open Microsoft Excel. Microsoft Excel files are binary files, but comma-separated values are text files, so I can open it freely in a notepad. And when you look carefully, unfortunately I cannot make it bigger, but just to symbolically have a look at this. The first line is specific because it contains the columns number, features numbers, yes? So this is the first feature, customer ID. Next I have a comma. By the way, comma is a symbolic in this name because that may be also a colon or semicolon or a space, simply, yes. So generally something separated data, yes. Next we have the next feature, which is gender, and then I have a comma. Next I have the next feature, which is age underscore first underscore order, and then comma, etc., etc. So the number of columns is the number of commas, apologies. Number of commas is the number of columns minus one. Yes. Yeah. If I have 3 columns, then I have 2 commas, and then come records. Okay. Each line is a separate record with our data. So the first we have customer ID, which complies with the name of the column in the first row. Then next we have a comma. Next we have F, which stands for female, etc., etc., etc. Once again, simple format, very popular. In many companies I work with, overused, definitely overused. And now a short discussion, maybe based on your own experience. What are the limitations of this format? It's nice because it's very easy to operate. I can open with a text file. I can double click and I get the Excel next, or I just simply push space on macOS and I get the snapshot, yes, without even opening the file. So it's very handy. But what are the shortcomings? What are the limitations of CSV in your opinion? How do you think? In which case you would avoid comma-separated value as a format of transferring your files, sending in for analysis or modeling.
Maybe REST API responses that you get in JSON.
Come on, it's just a file format. So what about REST API responses? It's just a file. It's not a service.
Yeah, but there are some ways where I think it looks nicer and it's easier to process when it's in JSON.
Wow.
It's maybe a job specific thing, but
yes.
We have such a
if you
case
just simply say this to the business user, okay, who is used to use Excel spreadsheet, says, okay, come on, it's much easier to see the pattern in the JSON. Wow. You know what I mean? You know why I'm laughing. Okay, but still, this is one perspective. You would like to have something more ordered, so just simply use JSON. Okay, but another limitations, other shortcomings. I'm talking mostly about now tabular data. Okay, so it's about tabular data, not semi-structured, unstructured data.
And maybe numerical data, because some people use commas and dot in decimal. It might be.
No, it's not a problem. Come on, look.
Oh, okay.
I have a lot of numerical data here, like, for example, if I open it with Notepad, I have, for example, this one. Can you see? This is GeoPoint, and there's no problem in putting a dot here when we have comma, something which separates. Nope. Okay, so maybe I will tell you. If you have a large file, that file type may be firstly very large for in storage. Large, I'll show you later on the example. Next, it may generate error when reading in or writing down. Okay, so it's a bit more risky. And now here comes the question of the size. What does a big data mean for you? Okay, this is the very important question to ask. Big data is very fashionable. And the first question, we have 834 kilobytes. Is it big data or not a big data for you?
Small data.
Small data, okay. So where's this limit? What should be the size? What would be the size of this data set? For example, as a comma separated value, which for you would mean, okay, I have starting to play with big data. What would be the size?
Well, I'd say at least tens of thousands of lines.
Okay, it's 10 of thousands of lines, so it's
at
still
least.
1 megabyte. So it's 1 megabyte.
Yeah, but it still gets to, well, big data is, I think, a bit flexible term.
Yes. Okay, so let's define it. What does it mean, big data? Just by intuition. Let's play with the intuition. We say, okay.
By intuition, big data would be something that you can't deal with it as a human looking at it, but you would want some additional tools to help you with that.
Okay, so for the most of the population, I know it should be 3 lines, yes, because I know I have 1, 2, 3 more. I'm joking, obviously.
Yeah,
Yeah,
you
but
can't, for example, do statistics manually or process
okay,
it easily
yes.
yourself.
So for you, this 834 kilobytes is big data. All right? Because
Depends
as
on
you can
the
see, I
amount
have
of records
so
inside.
because I have more than 10,000 here. I have more than 10,000 here. I have 11,000 in this file.
Yeah, so I would say I
This is big
would
data.
need
Okay.
to use some tools, so it could be big data. It could be.
Okay. Very good. Very good definition. Come on, it's intuition. Some other ideas? Okay, so what I might take away from the short discussion is that if I cannot cope with the amount of data by myself in my brain, that means it's big. Am I right?
Basically, yes.
Yep. Okay, so just to be more precise, there are a lot of different approaches to defining big data. The most popular is so-called 4-5 V's, big data, for 4 V's, and for example, image. As you can see, this is the most typical classification of, or different 4 dimensions of big data. We define it in the terms of the volume. So if the size of the data is larger than blah, 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 then we have big data. Variety, how many different types of the data we have in our data store. Veracity, how trustworthy is the data, because that generates the effort, for example, of checking the quality of the data. And velocity, how fast does it come to us if it's streaming, yes? So these are the most common 4s of being big. But from the IT perspective, your definition of big data as something which generates problems, yes, is almost okay, but we change the human brain to the processing power of the computer. So whenever a volume of the data is problematic for a computer to process, yes, we may start calling as a big data. Okay, so when it comes to our example, there's no problem with processing 1 megabytes of data for any computers you use, okay? But what would be the size of the data set when having your own experiences with the different analytical tools, that size would start making problems with data analysis? Do you have some feeling what would be that size? Not for human brain, but for the computer. 10 megabytes, how do you think? If you would like to analyze a data set of 10 megabyte size, would your computer hang up or not?
Depends on the computer, but
Come on, normal computer, you have it.
it wouldn't.
Yeah. Yes, it would. So 100 megabytes.
Still wouldn't.
Yep, 1 gigabyte.
Could be a bit slower, but still wouldn't.
Still 10 gigabytes.
Well, I think we're getting into the territory where it might start becoming problematic.
Yes, and 20 gigabytes.
Well, even more problematic. It might
It's
take a while to process.
Very, very, very problematic. And now imagine that I would like to open, even in Python, okay? Forget about Excel. I have the Python installed. I have some specific libraries, yes, and I import the 20 gigs dataset to my computer to make some simple analysis like statistical analysis. What would happen on my computer I work with at the moment?
Simple script. Probably you might get some error, or it would take a really long amount of time for it.
Why do we get the error?
Because you can run out of memory.
Bingo. Look, I have a hardware limitation. I have 16 gigabytes of memory in my notebook, okay? And I want to import 20 gigs. Yes, 20 is larger than 16. Error. Do you agree? So we slowly come to the definition of big data of something problematic, okay? And now here comes the question, what to do in situation when you have 20 gigabytes of data and you would like to still to analyze it? What would you do?
Partition it.
Bingo. And this is one of the ways how to cope it. But before, I will just simply slowly show you some path to the big data, okay, in machine learning. So the first file is simple. I have the comma-separated value file. By the way, I work for many different computers, big internationals, and you would be surprised how many people use comma-separated values as a way of transferring data in case they have very modern tools like databases or whatever, yes, but it's painful, but still they love it. CSV file works perfectly up to 100 megabytes. After it generates errors of many different types. Next, you have so-called Parquet. This is the format very similar to comma-separated value. The main difference is this is binary file, but when some of you maybe use Python, for example, with NumPy and Pandas, there's completely almost no difference when you'd like to save the data frame, Pandas data frame. Pandas data frame is the way how we store data in tabular format in Python. Yes, it's the most common library in data science. If you want to save it to drive, you just simply either say df dot to CSV or to Parquet. Okay, this is completely no difference whether you save it to Parquet format or CSV, but look at the difference. It's good to know Parquet, by the way. That's my favorite format for tabular data for larger files. Look, this is a simple comparison made on. You can do this experiment by yourself. I strongly encourage you to do such a simple experiment because you will have a look and feel how it works. If you have a data in a CSV file, comma-separated value, which is 1 terabyte, okay, it's not a problem to generate such a data set in Pandas. You simply generate a artificial random Pandas data frame. The same data stored in a Parquet file is 8 times smaller, 8 times, yes, on Amazon S3 bucket. But interesting thing happened if you'd like to process it. Look, to process this file, to read in, for example, make some simple computation, it takes 236 seconds when it's comma-separated value and 34 times less when it comes to Parquet. Obviously, if it's 1 terabyte, it's significant. If it's 10 megabytes, you won't even notice the difference, yes? But for larger files, it has a sense. But next comes the data scanned, but this is very interesting for you. If you'd like to compare the cost of processing for Parquet, it's almost 100 cheaper. So now, as you can see, in some cases, it's sensible for larger files, like more than 100 megabyte, to use a binary file to store and transfer the tabular data. Tabular once again. So it's a table, structured data set with numerical and categorical variables. We are not talking about images or natural languages. So this is the Parquet. The next option for you, which is also commonly used, is SQLite. This is a very handy solution. It's open source library, obviously. This is the SQL database, but nice thing about it is that you can store many different tables with different relations, but in a single file. Yeah, so just a portable database, one file format. So it's also quite nice. Not that often used, mostly by programmers. It's not common in data science, but still it's good to know that it's also possible to transfer the data in that format. And next, we come to partitioning. And look what happens here in the data echo. we may upload our files. We're going to do this in a few minutes from now, but then we can also connect to our file system. And in that case, we just simply point the data equal to the file system, a folder where we have all our data stored as, for example, hundreds of different files, which are partitioned, yes. The advantage of this is also that whenever we just simply exchange the data with the new versions, let's say after a week, okay, maybe some data change, it's all there. From the Python perspective, if you'd like to work with large files using partitioning, this is a very interesting Dask library. So for example, if you, okay, because once again, there is also another interesting habit among data scientists. They love to have everything in files like CSV, Parquet, whatever, and then make all those operations on data frames. So the general idea, the general flow of the data scientist, the most typical flow is that I have some data set in a file format, and then I just simply read it with pandas. Yes, pandas is a library for data wrangling in Python. By the way, I'll just simply show it to you. Pandas. Pandas and NumPy, those two. If you have, for example, 100 hours to learn machine learning, my advice is to spend around 15 hours on Python if you are completely newbie, 15%. Next, spend 30 to 40% on NumPy pandas, those two libraries, mostly pandas, and another 50% on machine learning. Why? Because pandas and NumPy, mostly pandas, are the key libraries for you, okay, for data wrangling. This is really, really key. This is the most important. And the pandas data frame is the way it stores data. Never mind, a lot of different books on this. If you would like to make a career in that area, even in times of ChatGPT-4, that's still the most important skill set. Never mind, coming back to our flow. Machine learning engineers love to import the data from a data set in the form of a file. That's why, for example, they love Dask, because it allows you to cope with huge amounts of data using that pandas data frame. My personal advice for you is to use SQL query, so keep the data set in the database and read the data to the pandas data frame using the SQL query, which is still possible. And then you avoid solutions like this one, which may also be limiting if you go over the 1 terabyte of data. Yes. So, but still, Dask is a very, very nice solution if you really love to play with huge data sets, but still with pandas data frame. So this is for partitioning. There is also a new star, which is polars. This is a very interesting alternative to pandas, precisely designed for large data sets to blazingly fast analyze this data set. It's not that powerful as pandas, but still does the job, especially in big data operations. So it's good to know, just keep it somewhere. It's being recorded, so that may be also useful for you. Okay, so let's come back. Partitioning. Next come the Hadoop system. This is not the lecture on big data, but just to give you the sneak peek of how does it work. Behind that family of solutions, yes, there is so-called MapReduce method or ideology, a set of methods. Yes, it was created by Google engineers many years ago. And the general idea is that you have the map process where you take a large problem or large data set and split it into the small data sets. This is map operation. Then you perform some operations on the smaller problems, yes? Like, for example, computing some statistics, whatever, and then you integrate the solution, sub-solutions to the final solution. This is the reduced stage, yes? It works both for files, and that's why we have this here, HDFS, which stands for Hadoop File System, and computations. And if you would like to, for example, look at the ecosystem, just simply Google Hadoop ecosystem, go for images. You'll have a lot of different images like this one. This is very nice. That's my favorite. And as you can see, you have many different solutions for file management, cluster management, data processing like MapReduce, etc., etc. A lot of different other open source. It's everything is Apache. Plume for data collection. Any questions till now, or it's clear?
It's clear.
Okay, let's continue. What else would you need if you would like to start your maybe next iterations of your machine learning process? Because in the first iteration, you'll probably work with single file. But later on, if you would like to, for example, train your model on the large amount of data, you will also need a set of tools for streaming data management, because generally the data may come to you from either static sources like SQL databases, as you can see, or not only SQL databases, which are for non-structured data. We're going to have a separate lecture only on this. Just as an introduction to the next topics, to the architectures and deployment. But there's also another situation where you, as a source of data, you will have a stream of data. So not batches, not data in the form of static batches, but in the form of streams. The streams may be logs from servers, there may be data from sensors, that may be messages from social media, there may be videos as input to the social media, yes, and lots of different streaming sources. And in that case, you would probably need to know how to manage such a stream. Yes, so we have different sources, and you have your final place to store, like data lake, probably for non-structured data, or some database, or the data warehouse, whatever. You need to have a kind of the middle layer, a set of tools to manage the streams, and the most important technologies for you in that area are first one is Apache Beam. Beam stands for batch and stream. So that helps you to efficiently manage both batch and stream data sources. It's a kind of the meta language. It's extremely efficient from the engineering perspective. So this is the first. If you'd like to, if you consider drifting your career into big data and machine learning, it's really worth learning Apache Beam or Apache Kafka just for streaming, yes. Kafka is another interesting, Apache Kafka, it's here. It's here, that's another solution for streaming data management, yes. Just
what about NiFi?
How do you pronounce it?
Apache NiFi, N-I-F-I.
N-I-F-I. I don't know it. I'm fast. Directed graphs. So it's for pipelining. Yes, am I right?
It has a lot of stuff to do, to be honest.
Okay, so I have no idea about this. So let me add this to my toolkit and I will have a look. I don't know. I'm not familiar with this. Okay. No comments. Could you please comment on this? How do you use it, or what's about?
It's well, in my case, it's used to transfer a lot of data that is we request it as a JSON through an API and feed it into dashboards. With transforming JSON, it allows to transform JSON to CSV files. A lot of addition to files. It's kind of like data eco, I feel. With those processes that you build with workflows, you can easily configure what you want done with your data in the process. It can generate files, it can do something with existing files, it can just transfer files, search logs, a lot of stuff.
Okay, thanks a lot. So it looks like it's focusing on data processing, am I right?
It is a lot. It's not just data processing, it's also, I don't remember the term used to describe it, to be honest, but I mean, by someone who told me about this tool, but it allows a lot of data processing, just moving data, getting data from SQL, turning data into SQL, like taking JSON into database, a lot of stuff.
So if I can compare it, for example, to Apache Beam is just only for transferring data. Okay? Just to managing the flow. Yes, just to make it as fast and as secure as it's possible. Okay? So that would be the difference. But if you have, for example, if you have a need for data format transformation on the fly, that's probably Apache. But as I said, I have completely no idea about this. Thank you very much for this. So whenever you have such tools at hand, I will be really grateful. Okay? So shall we continue?
Yes, of course.
Okay. Thank you very much. So just to wrap up, you may have stable data sources like databases or files or file systems, dynamic data sources like streaming. You have plenty of different solutions for this. Dataiku helps you to establish some connections both to SQL data sources and non-SQL data sources. In case you do not work with such a tool, you would need to do it by yourself using those libraries, as I said. Okay, but still, once again, just coming back to our case, today we are going to play with a very simple basic case where we have, our goal is just to create a proof of concept. So let's come back to our example. I have customers labeled. I can create a data set. And now, next step. What do we have here? Once again, use case is the following. E-commerce store, selling t-shirts globally. You have the history of your customers. For each customer, you have data like gender, age at the first order, user, age, and the brand. So, for example, this is the browser simply used by the person and the operating system, the country, with geolocation, and then whether this person came from the campaign, marketing campaign or not, how many pages on average she or he visits, and a label to predict. And first, practical example, remark. Whenever you study, in most of the courses online or books on machine learning or examples on Kaggle or medium.com, what I found, I find this training data set as a kind of the input. Yes. And then we just simply identify the algorithm, choose the best algorithms, train the baseline model, fine-tune the model, evaluate, sometimes deploy it into production and monitor. Never mind. And what's missing there is the huge effort made to put this table on table. I would say, what does it mean? What I usually do, it's a business part, but it's a key for you as a data scientist. Firstly, I try to make the subject of our prediction as precise as it's possible. So, for example, the managers come to me and say, Andrzej, Andy, we have that problem. We would like to predict whether the customer is a high revenue to us or not, based on our history. So now I need to, in many cases, make two workshops, two separate workshops. First workshop is devoted to the very, very precise definition of what do we really want to predict. This is this high revenue. The second workshop is devoted to the features which probably, yes, impact this label. And now the question to you, just to give you a feeling. You have an e-commerce store, a website which is successful. You have the huge show of interactions with your consumers. These consumers are happy, they purchase in your store. And now you would like to have a formula which for a given consumer will give you a label which is true for someone who is high revenue. If you look at the analyze here, we have only 9% of people who are high revenue and false for the others. How would you define this formula? What does it mean? High revenue for you. Do you understand my question?
High
You have a-
revenue is
Yeah.
dependent on what we need, I believe.
Okay, and I am very stupid data scientist. You are a very smart business owner, yes. And I'm asking, okay, but give me the formula for a given consumer. For example, Andrzej Wodecki. I would like to know whether this person is high ref or low ref. So what should I do to identify the value of this label?
Well, compare the costs versus what you earn for the company, and then create for myself an arbitrary breakthrough, rather a condition that if the revenue bigger than something, it equals high revenue
Good.
for me.
So imagine that, so you tell me, okay, compute this revenue, and imagine that you have it computed. So for each customer, you have a column, a feature revenue, which is in US dollars, for example. Like for Andrzej Wodecki, it's gonna be 450. For Kasia Kowalska, it's gonna be 200. Yes. So I have this column. Okay. And what next? Having that column, how can I identify whether the person is high ref or low or not? True
Well,
or false?
we either say that if the revenue is higher than something, and there's an arbitrary value we put in, you would be high revenue, or we can make a more complicated calculation that if you are in, I don't know, top 5%, top 10%, top any percent that we desire is your high revenue customer because you have bigger revenue than X% of people below you.
Very good. Very good approach. In this case study, in the Taiko tutorial, there is a hard threshold, $300, and they made it by hard threshold, yes? In the way that it split our customers into 9 to 91%, yes, ratio. And much more elegant would be to use, for example, deciles. Do you remember what's the decile in statistics? Okay, so
Is it centile?
no, centile is a tenth of the decile.
Okay.
Cent is 100, decile is for 10. Okay, so just a small recap. It's good to know basics of statistics. Imagine that we have, let's say, 20 people on board at the moment on our lecture, and each one has some height in centimeters. Okay, and I'm telling you that the median, okay, of the height of like people who attend this lecture is 170 centimeters. What does it mean? Median of the height of all of us in the group is 170. What does it mean?
Median is, it's not moda, it's like, wait.
It's not mode, it's median.
Median was the midpoint, basically.
It's the average, basically.
Nope. Median is not the average. If
Like
you
order the data from lowest to highest, and then you
yep,
choose the middle, or if you can choose the both two and then the average of them,
okay.
depending on the.
So median, the first interpretation is that if you order all of us in that ascending order, yes, in the height, the median is a person just in the middle. Yep. But it's not too easy to visualize and to understand for business users. So my advice to you, because the reason I'm telling you this now is that later on when you are going to inform the business user with the results of your machine learning model, you need to be able to speak as easy as it's possible, okay? Because you should avoid any statistical jargon. So my advice is to explain the median. In a second from now, we will go into the deciles. Median, the following. The fact that 170 is a median of our height means that half of us has a height lower than 170 and half of us has a height higher than 170. Do you agree? 50-50. Okay,
yes.
so the next question. What does it mean that first quartile of our height is 160 centimeters? First quartile is 160 centimeters. That means that
It's a midpoint between the smallest and the average value. So
no,
it's
quartile.
Quartile, yes, it's first quarter, so it's in the middle between. Okay, so the median value divides it in half. So
Yeah.
quartile is the value in half between smallest and median.
Okay, so but try to explain it in more easier to understand way. Just following my median example.
First
Okay.
quartile will be a point at which 25% of the people have smaller height than given value.
Bingo. So once again, that means that 25% of us has the height smaller than 160 and 75% has a height higher than. Do you agree? First quartile is 160. So that means that 25% of our population in this lecture has the height lower than, and 75% has the height higher than 160, okay? Hello? I can't see you, so okay, good. So now I'm asking you, okay, what does it mean that revenue at the level of $300 in the store? Oh no, what does it mean that the ninth 9th decile of the revenue of our customers is $300?
Is that 90% of people earn less than the amount given?
Bingo, and 10% more. Okay, so this is another dynamic possibility, as you previously mentioned, that will split our population into 9-1, yes, proportion, yes. And the nice thing is that it's gonna be dynamic. So, for example, when it comes, when we have the inflation at the moment at the level of 18%, yes, a few months from now it will dynamically make it higher as a threshold. Okay. So you can work with the size, for example. Yep. So it's up to you. It's gonna be dynamic measure. And believe me or not, this definition, it may take 1 or 2 workshops to be defined. Because in many cases, and this is next example, this is the next question to you, very practical. At the moment, we have around 10,000 of rows, 11,000 of cases in our database, yes, in our data set. Sometimes people ask me, Andrzej, I have only 200 cases. Is it enough for the classification model or not? What would you say? In other words, what's the minimum acceptable number of cases we should have in our data set to have some meaningful model?
It's case by case basis.
Yes, obviously, but on average, roughly, maybe some
On
intuition.
average, we can say, like with the phone service or the political service, they basically assume you need 1,000 to 1,100 people to have an accurate representation.
Mm-hmm.
So
Yeah.
it's vague, of course. There's a
Mhm.
lot of you can see that between different results that there is some variation. It can be a few percents even, but it's like the basic, like the general amount that you need, at least for classifying something with people.
Mhm.
For example, politics, right?
Very good example. And in machine learning, we say, okay, a few hundreds. I know some PhDs made on 40 examples, believe me, but it's a very specific case. But let's keep it 400 up, 500 up, yes, cases. But truly, for me, a bit more important is the ratio between positive and negative cases in the sample. So I'll give you some another perspective of meaning of the big, but for the training data set. And next observation, just a kind of the terminology. We are on the lecture on machine learning fundamentals. In many cases, in so-called binary classification. So this is the situation we have here. Binary classification means, firstly, this is the classifications we're going to predict the label, not a number. Yes, categorical variable. And binary means that we have only two different values of this label. In our case, it's false or true. In many cases, it's represented by 0 and 1, but 0 means null, 1 means full. These are not numbers in terms of the measure, yes, 0, yes or no. But generally, we call those labels as positive and negative. This is the most general naming convention. And the convention is that we name as positive that value of the label feature to predict, which is in minority. Okay, positive is something which is in minority. So in our case, the positive is true and negative is false. You should use to this because if you've misled those two, you will completely, in the different way, you will read, for example, the confusion matrix we are going to look at in a few minutes from now. So positive is a minority. And how do I remember this? I always keep in mind the example of HIV, HIV positive person, okay? Imagine that I go to the lab and I got the result, diagnosis that I'm HIV positive, HIV positive. It's not positive for me from my health perspective, yes, because it's negative, yeah. But the positive stands for this is called positive because much less people in the population have HIV virus compared to healthy persons. Yes, healthy from meaning that it does not have. Yep. So this is the next convention. And coming back to our big, meaning big in training data set, the healthiest ratio between positive and negative cases is 10 to 20%. Okay? 10 to 20. Not less than 5. And now let's start. Imagine that we have 50-50. Why it's not that healthy? How do you think? If we have, let's say, 50% of people in our data set which are high ref and 50% which are not high ref. Why it's not that healthy for our data set, for our modeling process? Okay, so I'll tell you. We can create a random model, and it will probably have the very, very good quality of the prediction, 50-50, yes? Simply. But there is another much more interesting and more common scenario where we have less than 10%, like 1% of positive cases. What might happen in such a situation? What do you think? You have only 1% of positive cases, or 1 promille of positive cases.
Again, depending on the size of the data set, but it's hard to train the model because like 99% of the cases are negative.
We have not enough data to identify the meaningful pattern which will quite well predict whether we are positive or not. Okay? Imagine the following situation. Imagine that you have preventing maintenance project in your manufacturing plant. Preventive maintenance means that your model, basing on the historical data from sensors, and from the history of failures of a given machine, will predict for this machine whether a given part will fail in a week from now. Okay? In order to do this, you need to have a history of failures for that type of the machine. But the problem is that it's a completely new manufacturing plant, and you do not have the history, yes? Or you have one failure. So it's very, very difficult to identify the pattern in sensor data to predict whether the machine will fail or not. We do not have too many learning samples, yes? And as you said, it depends also on the number of those positive examples. And the question now is what to do in such a situation from the machine learning perspective. Maybe you have some experience. If not, I will just simply give you some tips.
Do you repeat the question?
I can repeat. What to do in a situation where the number of positive cases is 1% of all the cases you have. And as we said, we aim to have it at the level of 10 to 20%.
We either try to get more data or
yes. And imagine that it's impossible to get more data. What then?
Then we cut off some false data.
Nope. Then you lose the experience. So it's like cutting off a part of your brain. Yes.
Yeah, but I also can't just copy paste the positive data, right?
No, that's gonna be the same. So it will add no value. Okay, I will tell you. There are many different approaches. In computer vision, for example, you have so-called data augmentation. So you generate extra positive cases by transforming existing cases. Like you have, for example, cats and dogs, yes? And you have very, very, very just a small amount of dogs, yes? So just simply take the pictures of dogs, just simply transform them, rotate, minimize, zoom in, zoom out, etc. Yes? So this is data augmentation. In machine learning, you have some very nice libraries to generate fake data. Yes, keeping all other relations intact. Let me see. This is synthetic. I will give you some very interesting article on this. This is a very good article. It's being recorded, so you will see it if you want. That the faker is a very simple one. It generates fake data, but a very simple case. SDV is my favorite tool of the choice because it can generate the synthetic data using machine learning and neural networks, keeping, for example, the distribution of data intact. By the way, this is the very interesting solution for a situation when you are hired to train the model in a company which is not allowed you to give you original data. Yes, because of the security. If you, for example, work for a military or some security sector and you have completely no access to the real data, so you can work with this. So we can generate extra data. Another solution, and this is another my recommendation, if you do not like online courses or videos, I prefer books. In my personal opinion, the best books on machine learning are created by Jason Brownlee. The best blog. This is a mathematician from Australia, and he has, in my personal opinion, the real talent of explaining hard things in the simplest possible way, keeping mathematics at the non-trivial level. So it does not make things too trivial. So it's a great balance between the theory and practice. For machine learning, he has a lot of different books. If you like reading books, these are the best I have ever found. Almost anything on machine learning, but he has also a very interesting blog. It's good to subscribe to his blog because his readings are really great. And for example, you can look for unbalanced data sets, how to cope with so-called unbalanced data sets on Jason Brownlee blog, and look at this. So this is a set of different feature engineering tools and machine learning modeling approaches to cope with unbalanced data set. Okay, so this is the next possibility. So data augmentation is the first thing. Working with unbalanced data set is another thing. And the third approach is extra original. If you have less than 1% of training data, my advice is to change the philosophy of training from the class supervised learning, where we have the training data set having cases with features and the label to predict, to the unsupervised learning, where we completely do not have labels. And if you look, for example, for the most important library in the world for machine learning, this is scikit-learn, you will see that we have the classification problem. Classification is what we are doing now. This is case where we predict the label. A regression problem, the same, we predict the number. But in both cases, I have a data set which has features and the label. The same for regression. But for clustering, hello? Hello, can you hear me? Because I probably have some problems with connection.
Yeah.
Yep. Okay, thanks a lot. Because on my previous lecture, I had a problem. Okay, so you can hear me now, yes? Okay, thank you. So look, this is PyCaret. This is one of the best libraries for AutoML. And if you go to docs here, modules, you will have in unsupervised learning, Can you see this is supervised? You have classification and regression. And for unsupervised, you have clustering, but you have also anomaly detection. And in case you have a really undersampled data set, unbalanced data set with less than 1% of positive cases, my suggestion is just to switch to anomaly detection and train the model to detect strange things, strange behaviors, and automatically mark them as failures or positive cases. Okay? So this is the way how, for example, the modern artificial intelligence-based cybersecurity solutions work. Okay? If you have the stream of requests to your server, they just simply monitor these requests for something which is strange. And if it's strange, this is anomaly detection, they just simply say, okay, let's stop it. So this is the case for how to cope with unbalanced data set. And the final solution, which is at your hand during the business workshop, is to redefine the target variable, this label. What does it mean redefine? You may ask yourself, okay, what does it mean for us that someone is high revenue? You say, okay, it's more than $1,000 in revenue, and may happen that it's 1% on only. So you can change 1,000 to 300, and then you have 10%. Only may keep it, let's say, at the level of 200. So if you just simply keep it, all those who have the revenue at the level of 200 or more, it may happen that you have 50-50, yes, 50-50, but then you add an extra condition who have purchased at least two things during last quarter, yes? So you add some extra conditions, so that limits this 50% to this 10%, okay? So coming back in the face of the target variable, which is something which we like to predict, definition, you should steer with this definition into direction to have it at the level of 10 to 20%. Do you understand? Can you hear me? Excuse me. Just a question, technical question.
Yes, we can hear you.
Okay, thank you very much. Because as I said, I had previously some. Any remarks or questions? Okay, so if not, let's come back to our example. So this is the first workshop on how do we understand something which we are going to predict. As I said, you won't find it in the books. Probably you won't find them in the books. You won't find it in the courses on data science, but this is the extremely important part of the process. So that's why I spent that amount of time on telling this to you. And the second workshop is focusing on those features. And once again, we have it done. Yes, we have it ready. We have them in the data set. But in practice, in the second workshops, I do the following. Okay, we spent hours on the definition of what we are going to predict our target variable. So now I'm asking you as a business owners, yes, business users or practitioners, what are the factors, what are the key factors which really impact being this true or false, high revenue or low revenue? And then people think, okay, gender is probably such a factor, or the country a given person lives in, etc. They imagine different features. So I make the notes, yes? I have a list, let's say 15 to 40 different, 30 different features, 15 to 20 in most cases, yes? And then I go to the different data sources, because in many companies you have this data spread over many legacy systems, like ERP systems, customer relationship management systems like Salesforce, or marketing systems like Google AdWords, or some logistics systems. So you'll have a lot of different sources. So you need to query this data, yes, combine them, compute them for each customer, a lot of different things, yes, just to get this training data set, okay? So once again, two workshops. First, let's define the target variable. Second workshop, let's define the most probable features, the most valuable features. Next, gather all the data, prepare the training data set. It takes a lot of time. 90%, in my personal opinion, 80 to 90% of the whole project, data science part of the project, I'm not talking about the deployment. Wow. And now it's quite easy. So I just simply, just to create the model, I click, open, go to lab, create the AutoML prediction, ask for the high revenue. A system in the background identifies the type of the problem. So it looks at my target variable, identifies that this is the categorical variable with two different values. So it's a binary classification. It has its own heuristic. Says, okay, if it's a binary classification, so let's start with training with random forest and logistic regression. They are probably the best choices. It chooses this and it trains the data for me, makes all, prepares the data for me, transforms it, etc. And I have the model ready. So 30 seconds. The model is trained. Model is trained. And what we can do now with the model? Firstly, we can go to actions and we can export this to Jupyter Notebook if you want. Yes, so let's make it. I can export it to Jupyter Notebook to have this code in the Python format. It's possible, as you can see, with the natural language explanation with all the data transformation, training, etc. It's not that pinky because it requires some dedicated data eco libraries, but still we have something in Python. So this is the first we can do. Next, if we go to actions, we can export the model as, and as you can see, as Java if you want, or as Python, yes, or as an MLflow. It's one of the most important packages to manage machine learning workflows and projects, or to Snowflake, which is not available in our license, or PMML, it's another format. So I can just simply save it and give it to the machine learning engineer to deploy it into production. Yes, so this is the next thing. Another thing I can do is that I can export model documentation, and this is very nice for you because if you click such export, it generates automatically the documentation for you. It will take a few minutes, so just not to lose our precious time, I will just simply give you the example of this because I have it on my Polish lecture language. I did it there. So I'll just simply put it here, and this is the report generated from the simple training. So as you notice, training took around 30 seconds. And it's good for you to know that you can generate, look, such a quite nice report, executive summary, methodology of training. Okay, how did you split the test into training and test data set? By the way, this is the same project, yes? Grid search, next, the distribution of the variables, data ingestion, processing type, yeah? Feature tuning, cross-validation, yes? Next, you have, with all the human rebuildable format, experiment results, yes? Alternative models, model results. So this is the model evaluation. This is so-called confusion matrix, yes? All the quality parameters, everything is here. Okay, can you see with all the, everything is interpretation. So once again, it's 26 pages of very nice report, which may be an attachment to your model training, or to your, for example, if you are doing your final project on the lab, that may be the support of the final project. So this is the next thing you can do. Okay, so I'll just simply import this because it takes too much time in the sections. Okay, any questions till now, or you can continue? Okay, so I can't hear you, so I assume that there is no questions. So now what I'm gonna do is to deploy the model. I deploy it to production, and I have the model deployed. So this is, as you can see, a machine learning pipeline. In rectangles, you have artifacts. These are the things. Yes, in most cases, these are files. This is the data set. This is the model. Things, results, which are then input to next stages. And in secular form, you have so-called components, which are a set of different transformations. That may be data cleaning. In that case, this is training. Okay, so this is very simple. You have the artifact, which is the data set, as input to the component, which trains the model. And the outcome, the result of this training is another artifact, which is the model itself. It's there. So as you notice, the training took us around 30 seconds, deployment next 10 seconds. Yes. And then we do the model just to predict the features for something which we do not know the answer for. So let's do it now. So what I'm gonna do now is I will import a new data set named customers unlabeled. And if you look at this data set, what's the difference compared to the training data set? An idea?
It has missing data, that's for sure.
Nope, no, that's not. It has some missing data. We do not know whether the former data set didn't have also some missing data. But if you look at the structure, because this is the key, this is the most important observation in my course, in machine learning fundamentals. What's the difference between the training data set and this data set? And believe me, this is the most fundamental case. It's not technical. What do we miss in this table compared to the training dataset?
Could you show the training data set again?
Obviously. This is the training dataset.
High revenue column.
Bingo. Look what happens. Why is that fundamental? I will just simply, let's recall my introduction lecture. Yes, from the first lecture 2 weeks ago. And now I'll just simply show you where are we now. Moment. Yep, it's here. The first thing we did was to take a training data set. The assumption was that it contains some pattern. Then we used two different algorithms, logistic regression and decision trees, to identify those patterns. Then we took the best of them, that stage was training, and deployed that into the production. This brain is this rectangle. Okay, so that was the training. Take the data set, inference the pattern, and save it as a model. Okay, so this is the brain in this PowerPoint. And now we're going to the inference stage, prediction stage. This stage is done, let's say, once a month by data scientists. And this is done instantly by the model user. So you ask the question to the model, to the brain, just to receive the answer. Yes? And how do you formulate the question? You formulate it in that way. You say, okay, look, I have a person here, which is a female, at the age of 39, using Chrome on macOS, comes from the United States, from this geolocation, and she didn't come from the campaign, and on average, She already visited 15 pages, yes? How do you think? You're that smart, my model, you are so wise, yes? How do you think whether this person will be a high revenue or low revenue? So the question is set of features, yes? But we do not know the answer, yes? In fact, we ask this model 927 features in one batch. So this is so-called batch processing, okay? So I say, okay, I won't bother you with one question on a time. I just have 927 different questions, okay? So I inject this into the model and expect what? How do I think? What do you expect from the model? What would be the outcome of passing this file via model?
Getting predictions?
Yes, so we would expect a data set with what?
High revenue.
Yes, you would expect this extra column prediction, yes? Am I right?
Yes.
Bingo. So let's play with this. So I take this model. I have this apply model on data to predict. Can you see score? As an input data set, I take this customers unlabeled, okay? Create recipe. I create the pipeline at the moment, precisely speaking. And I run it. When you look at the flow, now you can see very nice pipeline. We have a kind of the component, which is at the moment prediction, yes? Prediction component. It has as input two artifacts, a model and a set of questions. And the outcome of its action is a table which has, voila, prediction column, but also, what else do we get?
Get the próba true and próba false.
Yes. This is some, by the way, we ask this system to generate this for us. It's not obligatory. Generally, those systems work that way, that the model tells you the probability that a given person will have the value false or true, and later on it computes the final prediction basing on those probabilities which sum up to 1, yes? If we had 3 different values, red, green, or blue, yes? Or for example, I work on the project, the moment semi-project. It's quite nice, by the way, to predict the status of the project basing on the history. And they have in the database 3 statuses. Green means everything is okay, red, everything failed, and yellow, there's some risk at hand. And so we predict 3 values, yes? Green, red, and yellow. So that will give us 3 probabilities, yes? Which sum up to 1, and the final prediction, whether it's going to be green, red, or yellow. Here we have only 2 values, yes? By the way, we can analyze this, and we can see that the distribution is 87 to 13. So it's quite similar to this, but that's pretty this. So as you can see, we have this flow running. We have the model at work. So that's in short the whole process. We have trained the model. As you notice, we spent most of our time, most of our time on this feature engineering, feature definition, label definition, etc. Then the training itself with exporting into production was just trivial. As trivial as asking the model to predict. And the next step will be to evaluate the model. And that's going to be the topic of our next lecture. On our next lecture, we're going to dive into here in this training model evaluation. We are going to talk about the confusion matrix, decision chart, the threshold cutoff, and all that stuff. Yes, and continue with some other examples. Okay? So I think that's all for today.